Welcome. Let's solve Leetcode 2415, reverse odd levels of binary tree. So they give us a tree and they want us, that looks something like this. Let's make this bigger maybe. And they would like us to reverse the node values where the levels are odd. So just to be clear, the level of a node is the number of edges along the path between it and the root. So in this case, since we only need one edge to get from 2 to 3, and same for 5, they would consider 3 and 5 an odd level. So doing as what they ask, we just reverse the nodes and we get 5 and 3. And then the even nodes remain untouched. Okay. I think that's pretty straightforward and simple. Or, I mean, as far as the understanding of the problem, it's not too complicated. So let's begin. What I would recommend is there's a couple of approaches, but for me, I think the most clear or maybe a direct approach is to use a breadth first search. So what we'll do is we'll accumulate the nodes for every layer, for every level, and if we are on an odd level, we reverse the nodes. Otherwise, we carry on. Okay, let's try doing that. So what we'll do is we'll let's see. We'll have a queue that holds all of our nodes, and we'll start off with root. Let me make this bigger. It's fine. Okay, then we'll have we'll keep a variable to store the level. So the current level will be 0. And now we'll perform breadth first search. So we'll say, okay, while q. So what we'll want to do is we'll want to store each level's nodes. So in this case, the level nodes would be, well, for the first one, it would be, sorry, the next level's nodes. So we'll start off with for every level we'll have an empty list, and then we'll pop off all the nodes that are currently on the queue. So for we don't know the number of nodes, but we'll do it for that many times. And what we'll do is we'll simply actually would it matter? Doesn't matter here. Q.pop. Doesn't matter. So what I was thinking of is I was like wondering if we needed to use a deck here. Let me think. If we use a deck, yeah, actually we should use a deck. So what we'll do is we'll add. So we'll always add nodes, and we'll pop from the left and add to the right. Yeah, that's what we'll do. Pop left. Okay. Yeah, that makes more sense. So remember, when we're using breadth first search, it's kind of like a queue. So the double-ended queue makes it satisfy the queue, I guess, functionality. Okay, great. Now for every node that we pop off, we'll also add it to the current level. So l.append the node. But then we want to get ready for the next level. So in this case, imagine we're 2. We want to prepare for 5 and 3. So let's do that. So we'll say, okay, if node.left q.append node.left. And I'm just going to put this on one line just to make it more succinct. Now, actually, what I'm going to do here is actually leave it like this. Now this is a little bit nuanced here. So they tell us that we're given a perfect binary tree. A binary tree is perfect if all parent nodes have 2 children and all leaves are on the same level. So going back over here, if there's a left node, there has to be a right node. So we don't need to check the other side. We can just say, okay, we know there's a right node. So, and we can just do this as well. And that's because we know that the binary tree is perfect. It's a full tree. So we know if there's a left, there has to be a right. So that's something that I'm going to utilize since they give it to us. Okay, so now we want to check for the current level. So remember right now, the current level, what we're going to do is check if we're on an even level. So actually, let me do something right now instead. Let me do something like, okay, if it's level and 1. So this means I'm checking if it's odd. Print, I'm going to just print L. And I'm going to say, sorry, odd. Then I'm going to print L. I'm actually going to do the same thing. I just want us to see what's going on. So I'm going to print this out. And this would be even. So let's print this out. I want us to see what's going on. So let me print it out. Let's run it. So I'm not going to submit it. I'm just going to run it locally. Okay, great. Oh, actually, let's do something here. So this is not very helpful. There's too much stuff going on. So let's make it better. Let's do something like this. Let's say for node in L, and we'll print the value only. We'll print node dot, I think val, and then we'll do the same thing for even. Can get rid of that. And I just want us to see what's going on because sometimes it's helpful to get an understanding. Sometimes visuals are a little bit more helpful. So let's go back to this example here. So, oh, did I print it wrong? Level. Oh, sorry. One thing we don't do that I should have done is I need to increment the level all the way through. So that's why they all say even. This is great. This is all good. So the first level is even, and they have a 2. The next level is odd, 3 and 5. Next level is even. So now we have understanding what's going on. Okay, so now they tell us if we're on an odd level, they want us to switch them. They want us to reverse it. So what we'll do is remember. So in this case, when it's odd, it has something like this. It'll be 3 and 5. 3 and 5. Let's suppose we're on another level, past it. So remember, for each level, the number of elements double. So first level has one element, next level 2, next level 4, next level would be 8. So let's suppose, just suppose we're on level 0, 1, 2, level 3, which would have 8 elements. So I'm just going to write 8 elements. Don't worry about the actual value. So let me just do this and maybe 11, 12. Is that okay? That's 8 elements. So for every odd level, there'll be some. It doesn't matter. There'll always be an even number of rows. But what we can do is we want to keep in mind. I'm going to erase this one because I think it's a better visual if we look at this here. Let me see. Let's close this for the moment. I think so. What we can do is kind of something like what's the word? Like a swapping algorithm. So maybe we'll call this left, and over here we'll call this right, and we'll always swap them. So we'll just swap the value. So we'll say, okay, we'll set L equal to 0, the left pointer equal to 0, and we'll set right equal to the length of L. Remember, we're storing the level nodes here, -1. So then we'll just swap them, and then we'll increment L. So then L will be 1, and then R will be over here. Then we'll swap them, and then let's see how it looks when we swap them. So let's copy this down. So I'm just going to go over 2 examples. So remember first L was here. Sorry, yeah, here, and R was over here. So let's swap them. So when we swap them, we'll say, okay, swap them. This becomes 88, and this becomes 11. And then we increment. Now L would come over here. And then R goes, 1 closer. Then we swap them. So let's do this here. So then we swap these guys. So then this becomes 77, and this becomes 22. And then we decrement R and increment L. So then L will be here, and R would be here. And we do this until they meet up, and then we can just stop. So that's what we're going to do here. So we'll set maybe just left and right equal to 0, and right will be the length of L, -1. -1. And then let's swap them. So we'll say, okay, no worries. So we'll say at the level, the left node, just change the value. And same thing for the right one. So L right dot val equals. Let's kind of use this to our advantage here. So we'll say you go over here. Okay, that performs the swapping, and then now we just increment left and decrement right. Left plus equals 1, right minus equals 1. I did make a big mistake here. I forgot to use the while loop here. So while left is less than right, and we'll do this. Then we do this. Okay, so this does all the swapping. And then that's it. Then we just go to the next level, and that's it. We do need to return root. Return the root. So notice for me, it's interesting that all we needed to do is just switch the value. We don't actually need to switch the node. We can just switch the value, and that should be good enough. All right, let's check it. Okay. Oh, okay. My apologies. Okay, looks good. Let's submit it. Okay. A little bit slower than I expected, but let's see how we can improve it. Dec root left equals. This all looks good. Looks good. Looks good. Left, right. Yeah, looks fine. Not sure why it's slow, but let's submit it again. Sometimes, yeah, like sometimes the Leetcode, their timing is random. Sometimes it's random. But I think this is fine. We could have also used depth first search, but this is fine. We don't need to do anything else. If you found this video helpful or educational, please consider liking or subscribing. Other than that, have a wonderful day. Take care of yourself.